Recent reports indicate that the factory can produce a brand new Model 3 or Model Y every 40 seconds, an impressive feat that demonstrates the capabilities of Tesla's cutting-edge manufacturing processes.
In the heart of Texas, rising from the desert, stands a factory unlike anything the world has ever seen.
It takes really ingenious engineering to make everything happen smoothly. Every 16 seconds, a finished car leaves the production line.
At first glance, it looks like a giant block of steel and glass, but inside, it's alive. Cars roll out every 40 seconds, robots work non-stop around the clock, and the entire place runs almost by itself.
This is something truly revolutionary.
This is not just a factory, it's Elon Musk's vision of the future.
It's been a long time since something like that happened in the car business, but it's here.
So what's really happening inside? Let's step in and find out. Inside Tesla's Texas Gigafactory. When people talk about Teslas, they go on about the sleek design, the crazy speed, the range, and all the cool features packed inside. But here's the part almost nobody thinks about. Where do these cars actually come from, and how are they built? The answer takes us to Texas, where Tesla built Giga, Texas, a factory so massive it feels more like a city. If you drive into the parking lot, you won't even be able to see where this thing ends. Forget fancy curves or flashy design. What you get is a massive gray box that sits along the Colorado River, right at the edge of Austin. The official address is 13,001 Tesla Road in Del Valle, just outside the city. Construction kicked off in July of 2020, and when it was ready to open, Tesla didn't settle for scissors and a ribbon. They threw a wild party called the Cyber Rodeo on April 7th, 2022, complete with neon lights, music, a drone show, cowboy hats, and about 15,000 guests. The size of this place is what blows people's minds first. The factory sits on roughly 2,100 to 2,500 acres of land. Inside, there are over 10 million square feet of production space. To picture that better, the roof alone stretches close to 3/4 of a mile in length and more than 1/5 of a mile across, about 3,830 feet long by 1,130 feet wide. By total volume, it is one of the largest buildings in the world. When Tesla opened the doors, it felt more like a stadium show than a factory launch. Videos online show people dancing under flashing lights as drones painted images in the sky. For a night, the place didn't feel like an auto plant at all, but after the buzz wore off, the real story became clear. This wasn't just another car plant. This was what Tesla calls the machine that builds the machine. That phrase may sound like marketing, but here's what it really means. The building itself is designed to act like one massive system. Every step, from the very first raw material to the final inspection, is linked in a straight line, so things move smoothly. No wasted zigzags, no parts getting dragged back and forth across the floor. The entire flow is designed to cut time, cut mistakes, and keep everything moving forward like a river. When you walk inside, two things hit you immediately. The first is how straight the layout is. It feels endless. The second is how humans and robots work side by side. The long floor lets parts move in one main direction, while wide lanes sit right beside the lines, so material can travel smoothly without clogs. Overhead, the power lines, air pipes, and cooling systems are tucked away to keep the floor clear. Paths are painted on the ground to keep order. It's not flashy, but it's what makes the whole machine run without drama. And then you reach the true monsters inside, Tesla's Gigapress machines. These are giant high-pressure die casting presses that squeeze molten aluminum into molds to create massive car sections in a single shot. Instead of welding together dozens of small brackets and panels, Tesla pops out one big piece, ready to go. They buy these presses from an Italian company called IDRA. The biggest one installed in Texas is a 9,000-ton press built for heavy underbody castings. Before that, Tesla was already using 6,000-ton presses for large rear sections of cars. The benefits are fewer parts to weld, fewer robots needed, less time per car, and far fewer chances for things to get misaligned. This is how Tesla cuts down takt time, which is just the rhythm of production, the amount of time one car spends at each step. A casting cell is something to see. You've got a press the size of a house sitting on the floor, with a furnace nearby keeping the aluminum melted at the right temperature. Robots scoop up the metal, pour it into the press, and the mold slams shut with crushing force. Metal rushes in, cools, and then a robot pulls out a single massive piece that replaces a forest of smaller welded parts. From there, conveyor belts or carts take the part away to cool before machining. The whole process is loud, hot, and bright, but it runs like clockwork. That idea of one big piece instead of many is what Tesla uses to slash wasted steps before assembly even begins. Now, don't think all this automation means there are no people here. That couldn't be further from the truth. By late 2023, over 20,000 workers in the Austin area were tied to this factory. You've got casting technicians, line operators, software engineers, maintenance crews, inspectors, and controls specialists. The robots do the heavy lifting and repetitive jobs, but people are the ones training them, checking the data, fixing problems, and improving the system. And the robots themselves are worth noticing. The tall orange and white arms are the industrial robots, picking and placing parts, applying glue beads, or lifting panels. On the floor, smaller platforms roll around. These are AGVs, automated guided vehicles. Think of them like driverless carts carrying parts between stations. They follow digital maps of the factory, avoid obstacles, and keep forklifts out of crowded lanes. Tesla even has job openings just for running these robot fleets, which shows how central they are to the whole process. Another backbone here is data. Every single station spits out numbers, how long each step takes, how many good and bad parts roll through, which sensors trip, and what cameras catch. All that data creates a live picture of the factory's health. Instead of waiting for a motor to burn out, Tesla watches for small changes in vibration and heat to swap it early. Instead of discovering a flaw at the end, cameras and lasers catch it as soon as it happens. This predictive maintenance system is one of the smartest upgrades Tesla keeps expanding at Giga, Texas. The building itself helps make these changes easy. Utilities run above or below the floor, so they can be rerouted without a fight. Mezzanine levels hold spare parts, walkways, and maintenance access, so crews can work without halting production. Heavy casting zones are built with wide open space for cranes, cooling systems, and mold swaps. If something big needs to change, there's room to do it without stopping everything else around it. But all of this would fall apart without solid logistics. You need to move raw material in and finished cars out. Tesla built the site right off a major highway for trucks, and in nearby Taylor, there's a modern rail hub where they load cars directly into drive-through auto racks. That keeps thousands of finished vehicles off the highway and speeds up long-distance shipping. If trucking gets clogged, the rail hub gives Tesla another escape route. And to clear up a few terms so nothing gets confusing, a Gigapress is IDRA's brand name for these huge casting machines. When you hear people say 6,000 ton or 9,000 ton, that's the clamping force, the pressure used to hold the mold shut while molten aluminum shoots in. More force means bigger, more complex castings without leaks. This factory doesn't stop. It runs day and night across multiple shifts. That doesn't mean every section is always at full blast. Casting, painting, body assembly, general assembly, and testing all ramp at different speeds, each with its own bottlenecks. But the target never changes. Keep the material moving forward, keep the flow straight, and don't bounce parts around the floor if you can avoid it. If you walk around, the design choices jump out. Raw material is delivered close to where it's used. Casting cells sit right next to the body framing, so the massive underbody castings don't have to travel far. Inspection systems are built right into the process instead of sitting at the very end. Distances between steps are kept short on purpose because shorter travel means less wasted time and fewer risks. Even how people move is planned down to the details. There are footbridges so workers don't have to dodge carts in busy aisles. Marked crossings with lights exist in the few spots where they do have to cross. Safety patrols watch hot zones around furnaces and presses. Training rooms are located near the floor, so new hires can practice right next to the real machines. Everything is set up so the system runs smoothly without chaos. And that explains why Tesla spread the building so wide along the river. They didn't squeeze it into 10 stacked floors like a city skyscraper. They laid it flat so trucks could stage, suppliers could drop off massive loads, and new areas could be added without shutting the rest down. That wide footprint makes it easy to expand when new processes or lines need to be added. The huge cyber rodeo party on opening night wasn't just for show, it was Tesla sending a message. This wasn't just another plant, it was the new headquarters, the company's main base. By moving their headquarters here, Tesla made sure top leadership is right on the ground. That means decisions about new lines, process changes, or wall moves happen fast because the people making the calls are standing in the middle of it all. The most important detail to remember is that it's still a human operation. Engineers tune the curves on the casting presses. Maintenance crews show up at 2 in the morning to swap out valves before the next shift. Quality inspectors tweak the cameras so tiny paint flaws don't sneak past. The robots do the heavy lifting, but the people keep the place alive. Now that we've seen how this giant plant works on the inside, let's look at what actually rolls out of it and the new battery tech powering it. What Tesla really makes in Texas. All right, let's get into what actually rolls out of Tesla's giant Texas factory. Giga Texas has two main stars on the production floor right now, the Model Y and the Cybertruck. For the Model Y, this is Tesla's US hub outside of California, and for the Cybertruck, this is home base. Back in April of 2025, the factory hit a big moment. The 400,000th Model Y came out of Texas. Tesla didn't brag about it with some boring press release. They spelled out 400K with rows of bright red Model Ys on top of a parking deck and let local spotters catch it on camera. That's about as Texas as it gets. What it tells us is simple. Model Y is a big deal here, and this place is cranking them out in serious numbers. And if you live anywhere east of the Rockies, odds are your Model Y came from Texas, not California. That's been the whole idea from day one. Put a plant in the middle of the country, so shipping cars to the eastern half of North America is faster and cheaper. Now, the one that steals all the headlines, the Cybertruck. The very first production Cybertruck rolled out of this same Texas building in mid-July of 2023. Austin is the main spot where that wild stainless steel truck gets built. That stainless skin completely changes how the body gets stamped and finished. And to pull it off, Texas got a Gigapress with 9,000 tons of clamping force. It's one of the largest machines you'll ever see in auto production. Here's something people mix up a lot, so let's keep it clear. Giga Texas does not build the Tesla Semi. The Semi program is based in Nevada. Tesla has a dedicated section at its Nevada factory for that truck, and the company has said they plan to start production there by the end of 2025 and scale it through 2026. So if someone tells you the Semi is rolling out of Austin, they're dead wrong. Now, let's move to batteries, because this is where the Texas story gets even more interesting. You'll hear the number 4680 a lot when people talk about Tesla batteries. That number is just the size of the new cell, 46 millimeters wide and 80 millimeters tall, which is about 1.8 inches by 3.1 inches. Inside, it has a tabless design, which basically means the current flows better, with less heat and less waste. Back in 2020, at Tesla's Battery Day event, they said this format would mean more energy per cell, more power, and cheaper cost per kilowatt hour. Those were the big promises, and while not every goal has been nailed yet, the cell itself is real and in use today. Here's what matters at Giga Texas right now. The Cybertruck uses packs based on the 4680 format, and Tesla's own impact report from 2023 proves it. The report even included a battery passport for the Cybertruck that calls out 4680 cylindrical cells and a structural pack. A structural pack just means the battery isn't only a battery, it's also part of the truck's floor and frame, adding strength as well as storing energy. That fits perfectly with how Austin builds cars. Fewer parts, stiffer structure, and simpler steps. Think of it this way. When you use bigger cells, you need fewer of them to reach the same energy level. Fewer cells mean fewer welds, fewer wires, and fewer tiny parts to deal with. That doesn't magically fix every problem, but it makes the pack easier and faster to put together, with fewer chances for mistakes. Now let's be real about the progress. Through 2024 and into 2025, reports about the 4680 program have been mixed. Some say the cells still haven't hit the cost and energy goals, and leadership has been pushing hard to get results. There were even rumors about pausing lines if fixes didn't land quick enough. On the other hand, other updates showed cost cuts, process tweaks, and volume gains that moved the cells closer to the targets. The truth is right in the middle. The format is real, it's powering trucks, but hitting every target is taking longer than the early hype suggested. That's normal for brand new battery tech. And Tesla isn't betting everything on just one type of battery. They still buy cells from partners. Panasonic makes cylindrical cells in Nevada. LG Energy Solutions supplies 2170 cells for several Tesla models, including some Model Ys from other factories. A 2170 cell is about 0.83 inches wide and 2.76 inches tall. Many Model 3s and Model Ys use these. For Austin, here's the key point. Cybertruck is built with 4680 structural packs, while Model Y can come with either 4680 or 2170 packs, depending on the trim. Model Y production in Austin looks familiar. You've got stamping, body, paint, and final assembly, the usual flow. Texas was actually the first US site to ship out Model Ys with 4680 packs back in 2022. But plenty of Model Ys here still use the 2170 packs. That flexibility is by design. It keeps the lines busy while the new battery system ramps up, and customers don't have to worry about picking packs when they order. You just pick your trim, and Tesla sorts it out. On the Cybertruck side, it's a whole different ballgame. Stainless steel panels change how the body gets formed, and don't forget about the stainless steel itself. The shiny outer skin doesn't come straight from Austin. It's supplied by steel mills, including one in Sinton, Texas, that was built to produce flat-rolled steel for projects like this. The coils arrive at Austin, get cut, shaped, and turned into the Cybertruck's panels, so when people say exoskeleton, that's what they're talking about, those steel panels built into the truck's outer shell. And why did Texas get the Cybertruck instead of another site? Simple. The building is massive, the layout is straight, and the land around it makes it easy to bring in huge presses and move big parts. That long rectangular footprint gives body and casting areas the elbow room they need. When you're figuring out a brand new type of build, that kind of space isn't a luxury, it's a necessity. So we've seen the products rolling off the lines. Now let's look at the scale of it all, how fast Texas can really move, and why that speed is shaking up the rest of the auto industry. The truth about Tesla's Giga Texas output. Here's the part everyone really wants to know. How fast can Giga Texas actually pump out cars? In Tesla's own update for 2024, they laid it out. Giga Texas is set up to build more than 250,000 Model Ys a year and more than 125,000 Cybertrucks a year. Put that together, and you get over 375,000 vehicles a year when the place is fully cranking. But here's the deal. That's installed capacity. That just means the machines and lines are built to handle that much. It doesn't mean they're rolling out that many today. The actual number depends on how smooth the line is running, how steady the supply of parts is, and how often upgrades are going in. That's the part most people miss when they see the big number. Now step back and look at Tesla as a whole so you see where Austin fits in. Across all of its factories, Tesla's total installed vehicle capacity in 2024 was about 2.35 million vehicles a year. That includes Fremont in California, which can push more than 550,000 between Model 3 and Model Y, plus Model S and Model X. Then there's Shanghai, close to 1 million a year. Berlin lands in the hundreds of thousands. Add Texas into that mix, and you see it's not the biggest single plant, but it's one of the heavy hitters, especially on the US side. And keep in mind, it's still climbing into its full stride. The proof is in the milestones. Texas has produced over 400,000 Model Ys. That only works if the line has been running steady and strong, and we know it has. Back in 2022, output was about 1,000 Model Ys a week. By the end of that year, it was hitting 3,000 a week. By spring 2023, 5,000 a week. Add that up, and you hit 400,000 total by 2025. Now the question everybody's been throwing around, what about Cybertruck? How many has Texas made, and how fast is it ramping? Here's the straight answer. Cybertruck is brand new, and the ramp has been slower than something like the Model Y. That makes sense when you remember what it's made of. Stainless steel body panels and giant one-piece castings aren't the norm in car factories. Those things take time to get right. In 2024, Cybertruck sales were just under 39,000. Through 2025, the line kept climbing, but with ups and downs as tweaks went in. You'd see lots filling up with trucks when a batch cleared checks, then quieter stretches if a new tool or software update was being added. That's not failure. That's exactly how new lines work when you're making something this different. Planned stops are part of the deal, too. Around the 4th of July week in 2025, Texas took a short pause for maintenance and upgrades. Every car plant does this. You shut down for a few days, swap out equipment, roll in new tools, push software updates, then fire it all back up. It doesn't lower the installed capacity. It's how you keep things healthy long-term. With a new product, bottlenecks are normal. Stainless steel panels need special forming, giant castings take trial and error, paint shops can slow things down, and even final checks can stack up until the line smooths out. And once Tesla shows they can do this, other companies pay attention. Big die casting wasn't a serious topic before. Now, Toyota says it's going to use Giga casting to make major body sections in huge single pieces as part of a new modular design. Volkswagen has also talked about using big castings to cut build time on future EVs. The point is simple. Once one company proves you can cut parts and welds and save money, everyone else at least tests it. Because time saved on the line equals money saved per car. Meanwhile, the rest of the car industry has been rethinking its timing. The EV market's been shaky, so some makers are slowing things down. Ford said it was pushing back some EV launches while it works on cheaper platforms and a low-cost electric truck targeted for 2027. GM told investors it won't force a 2025 target just to hit a goal. It's going to let demand set the pace. And that's why ideas like huge castings and simpler lines are catching attention. They cut cost. And right now, that's the game everyone is chasing. So let's bring it back to Texas. When a factory starts cranking out giant castings and simplifying lines, suppliers feel it too. You need fewer small tools but bigger machines. And by early 2024, press makers were already bragging about massive new orders from multiple brands. And that's not the only reason Giga Texas stays in the news. In January of 2025, Tesla said it was setting up Cybercab lines in Austin, with full production planned for 2026, and that it expected to launch a robo-taxi service in parts of the US later in 2025. A few months later, in June, early pilot rides started rolling in Austin. Business Insider wrote in them and reported it was invite-only at first, with a small fleet charging a flat fee. Whatever you think about robo-taxis, it shows how Tesla views Texas. It's not just a car plant, it's the launch pad for their next big bets. The numbers tell us how big Giga Texas is, but what doesn't get talked about enough is how this place is powered and the new tech being tested inside. The hidden side of Giga Texas. You've seen how massive this place is. You've seen the cars rolling out. But here's the part most people never think about. What actually keeps Giga Texas alive? How is it powered? How did Tesla even pull off building something this huge? And what's this new robot project happening inside that might change how the whole place runs? None of this is the flashy stuff you see in Tesla ads. Let's start with power. On the roof, Tesla isn't just tossing up a few panels for show. They're planning a solar setup that's huge. We're talking 32.4 megawatts of rooftop solar. That's 32,400 kilowatts of power at once. To make it super simple, that's a massive amount of juice, and it's not just a small pilot project. This is the kind of solar build that actually makes a dent in powering a building this size. And they're not stopping there. Tesla also filed plans for on-site batteries, so the factory can soak up solar power during the day and then use it later. Think of it like the world's biggest power bank sitting under the roof. It saves money, it cuts grid use, and it keeps the place running smoothly. Now let's talk about water. Tesla filed plans to take almost 4 miles of riverfront next to the factory and turn it into a public eco-park. But here's the catch. It's not just a park for walking trails and trees. It's also flood control built right into the landscape. The plan shows a 2-acre rain garden, 6 treatment ponds, rows of bioswales, basically shallow planted channels that guide and clean rainwater, and even brand new wetlands along the river. The idea is simple. When it pours, the water doesn't just blast off the roof and concrete straight into the river. Instead, it gets slowed down, filtered, and soaked up before it moves on. On normal days, it's just a park where you can walk, bike, or hang out. The filing says 3.8 miles of trails, about 290 acres of green space, and up to 3,000 trees planted each year. They even want to use reclaimed water, cleaned but non-drinking water, for irrigation, so they're not wasting fresh water on lawns. Sounds great, right? But here's the flip side. Since 2023, regulators in Texas flagged Giga Texas for air and water violations. We're talking spills, emissions issues, stuff like that. This isn't shocking. Giant factories everywhere get citations. But it's worth knowing. Tesla had to tighten up its systems because of those notices. So while the eco-park and solar panels look good on paper, the reality is regulators are keeping watch. And this is where things get political. Giga Texas isn't actually inside Austin's city limits. It sits just outside, in what's called the ETJ, which stands for Extraterritorial Jurisdiction. That just means the land isn't in the city, but still has to follow some of the city's rules. But in 2023, Texas passed a law that let landowners bail out of the ETJ if they wanted. And in 2024, Tesla did exactly that. Leaving the ETJ means fewer city rules and more state and county rules, which usually aren't as strict on things like flood control. People who support the move say it cuts red tape and makes it easier to create jobs. People against it say it weakens oversight and gives Tesla too much wiggle room. Both sides make sense. What matters here is that the rulebook for Giga Texas literally changed, and now different authorities are in charge of keeping an eye on it. Now let's rewind to how this monster even got here. Location was everything. It's right next to State Highway 130 and the Colorado River, which gives Tesla shipping access, water, and tons of room to expand. But there was another factor: money. In 2020, Travis County approved a property tax rebate worth about $14 million over 10 years. The local school district, Del Valle 1 SD, also approved a Chapter 313 agreement, which capped the site's taxable value for 10 years. The Texas Comptroller's Office said that deal was worth around $46 million. Put those breaks together, and it became part of the reason Tesla picked Texas instead of Oklahoma, which was also competing for the factory at the time. And people are still debating those deals today. In 2025, when local leaders were talking about new taxes to cover flood recovery, residents asked if Tesla's tax breaks should be revisited. County leaders said the contracts are locked in, but they're reviewing compliance to make sure Tesla is holding up its end of the bargain. Love them or hate them, those deals are still in place. Tesla met its job numbers, but officials are keeping a close eye on the environmental side. Now let's get to the part that makes everyone lean in, the robot. Optimus. You've seen it in clips. It's human-shaped, with legs, arms, hands, and sensors where the eyes and ears would be. The pitch is straightforward. Instead of designing weird robot-only spaces in factories, why not build a robot shaped like a human that can walk into a human station and do the same work? Elon Musk has repeated over and over that the first big Optimus rollout won't be in homes. It'll be inside Tesla's own factories, starting with Giga, Texas. In 2024 and 2025, he even said thousands of these robots could be in Tesla plants by the end of 2025, if things go well. Here's the reality check. Right now, Optimus can walk, pick things up, place them down, and do simple balance moves. So factory work would start with boring but safe tasks, like moving bins, pressing buttons, feeding parts into a machine, or holding items while a camera inspects them. Safety and cost are the two big hurdles. Robots have to be safe around people, reliable enough to not screw up the line, and cheap enough to make sense compared to hiring someone or just using a fixed robotic arm. That's a high bar. Even engineers who've worked on it have said, don't expect miracles overnight. So why even bother with a human-shaped robot? Because it saves money on redesigns. A robot shaped like a person can be dropped right into a station without ripping apart the floor or walls. It just uses the same tools and spaces humans already use. Over time, as software gets better and hands improve, the same robot can take on more tasks without Tesla having to build new machines. From the way it's powered, to how the land is managed, to who or what does the work, Giga Texas isn't just a car factory. It's the test run for how Tesla wants to build everything in the future. Thanks for watching. See you in our next video.